Hello guys, welcome back to the channel. In this video, we are going to talk about the graphing capabilities of ArcGIS Pro with a couple of different examples. Now, when it comes to the graphing capabilities of ArcGIS Pro, there are a number of different options that you can go for. Now, this includes things like regular charts such as bar charts, line graphs, scatter plots, pie charts. In addition to this, you also can use ArcGIS Pro to generate various other kinds of graphs as well, such as histograms, heat maps, 3D charts, time series charts, and even maps with graphs. So you can imagine that graphing capabilities in ArcGIS Pro by itself is actually a huge topic. So in this tutorial, what we're going to do is we are going to pick 3 types of graphs to discuss with you guys, which can basically give you some sort of an insight to these overall capabilities of ArcGIS Pro when it comes to its graphing capabilities. So without further ado, let's jump in and get started with the first kind. So in this first example, I will show you how to create a bar chart using a simple GIS dataset. Now, to demonstrate this to you guys, the first dataset that I'll be using is going to be this geology dataset. Basically, what I have is a shapefile of Switzerland which shows different geological types. So what I can do is I can simply just use the .shp file and drag it and drop it over here. And that should take me to the geographical location of this particular dataset. And as you can see, it's basically showing us different geological types. You can further investigate the attributes table if you want to be specific about what sort of information that we have over here by right-clicking over here on this layer. And if you head over to attributes table, you would be able to see that we have a couple of different fields. We have name. Well, this GLG basically indicates the geology type. And I'm not going to get into the details of this each of these different geology type, because that itself might not really be relevant for this particular tutorial. And not to mention, I have actually done a separate video discussing this same exact dataset. But in this case, just understand that we have a number of different geology types under this GLG column. And over here, we can see that it basically shows us the area in hectares. So if I right click over here and go to symbology, and instead of using single symbol, if I use unique values, and now if I color this by this GLG field, maybe let's go with a different color scheme, something like this. And with this, you would be able to see how the distribution of different types of geologies have happened across Switzerland. And in this tutorial, since we're talking about the graphing capabilities, what I'm going to do is I'm actually going to create a graph which can show us the total area of each of these different types of geologies. Now you can see that if I select this row right over here, a small part up north gets selected, which has the geology type Q. And if I select the second row, you can still see that the geology type is still Q, but that's basically distributed across a different region. However, I would like to sort of aggregate all of these different geology types and display it in a graph, just so that I would be able to actually make different inferences or gain different insights by that piece of information. For example, what is the most common geology type that's present within these boundaries of Switzerland? So to do that, what we can do is we can basically right click over here on this layer. This is the layer that I imported, and we can go to create chart. And what I'm going to create is basically a simple bar chart. So let's click right over here. And I think for the time being, I can get rid of this symbology panel as well. Now, as soon as I selected bar chart, you can see that this sort of an empty space gets created. This is basically the place where the graph will be displayed once we make the appropriate selections. And at the same time, you can see that we can switch between the graph, which is not yet present, and the attributes table, which is always a helpful reference to have whenever we want to go back and check specific pieces of information. Now, coming back to the chart, over here we have to select category or date. Now in this case, if you basically expand this drop-down menu, you can select by which category we would like to create our chart. And in our case, that's going to be by the category geology. And if you can recall, the field name was GLG. So as soon as I do that, you can see that for each geology type, I get a specific bar, and that's displayed over the x-axis. However, what gets displayed over the y-axis might not really be that meaningful at this particular point of time, because under aggregation, we are not really going to select count, but we want to select sum. And what I would like to do is I would like to sum all of these different areas which are corresponding to each unique geology type together. And what do I mean by that? For example, if I double click over here, you can see that all of the different geology types are kind of getting grouped. And what do I mean by aggregating similar geology types? For example, let's say if we refer to this geology type C, I would like to get the aggregated value of this piece of polygon as well as this piece of polygon over here, which will give me the total area which corresponds to this geology type C. So that's what I'm after. And in this case, you can see that once we add these two up, it should end up giving us something close to 12,000 roughly. So we'll keep an eye on that as well. Now let's head back to this graph tab. And from here, we will have to select which numerical field that we would like to sum up. And in this case, as I explained to you guys, we would like to sum up this area field. And as soon as we do that, now you can see that it basically summed up all the similar geology types and grouped them into one specific bar. And if you can recall this geology type C, I told you that it should give us a value that's close to around 12,000. And if you just put your mouse point over here, you can see that the summation of the area is basically 12,053 hectares. And we could basically check those different properties for these other bars as well. And one cool thing is that when you actually select, or when you make your selections right over here on the graph, you can see that over here on the map, the corresponding areas get selected as well. And since we have color coded each and every different geological type, you can see that this color and the color that has been assigned over here is basically the same. So you can very quickly make decisions and inferences just by looking at this graph. For example, what are the most common geology types, things like that. And for example, if I click right over here, you can see that this specific geology type is basically distributed almost throughout the entire southern part of Switzerland, which accounts for a total area of about 546,197 hectares. And at the same time, you can also get an idea about the geology types that are rarely to be seen. For example, this geology type accounts for only about 4,249 hectares. So as you can see, when we have access to this kind of charts, it makes our life way easier when we really want to make interpretations based on our GIS datasets. And by looking at this graph, you can see that certain things when it comes to how this graph is being presented might not really be that appealing to you guys. But don't worry, you can actually make customizations according to your preferences by simply heading over to these different tabs right over here. For example, if you head over to this Axis tab right over here, as you can see, you can actually make a number of different changes to this graph. You can change things like the maximum bound. Let's say instead of having this number, if you'd like to have, well, by the scale, let's say if I wanted to have 600,000 as the maximum number, you can see that this upper bound basically gets applied to the y-axis accordingly. And if you head over to this general tab, that's the place where you would be able to make changes to these titles. For example, if you would like to change the main title of the chart, something like Geology by Area, Switzerland, and of course the x-axis, we can make that to be Geology, and y-axis, we can, well, refine it just a little bit by saying that's the area displayed in hectares, and so on. Alright guys, so that's our example number 1, how to create bar charts based on a simple GIS dataset like this. Now let's move on to example number 2. And in example number 2, we are going to discuss how to create a time series from a simple dataset. Alright, for example number 2, I will be using this dataset which I downloaded from Kaggle.com, which shows the accidents, the recorded accidents in New York City. If I open up this CSV file, this is how it basically looks. As you can see, we have a number of different columns. We have the crash date, crash time, zip code, lat long, and some information about the contributing factor to the accident, as well as the vehicle type. And what's quite important for us in this dataset, of course, in addition to all this other information, is actually going to be this latitude and longitude columns, especially if you want to plot this dataset on a map. So that's what I'm going to do. I'm just going to close this dataset for the time being. And let's drag this and drop it over here and get it into ArcGIS Pro as a table. And if you would like to plot, of course, all you have to do is just right click over here and go to Display XY Dataset. And from here, just make sure that you have mapped the correct fields to X field and Y field. In my case, it's going to be latitude and the X field is going to be longitude. And since we are working in lat-long, our coordinate system is going to be Geographic Coordinate Reference System, WGS 1984. And once you click OK, it'll take some time for ArcGIS Pro to import this dataset, and as soon as that's done, you might see a bit of a distortion in case if your native coordinate reference system of the map was something quite different. So what I'm going to do is I'm going to head over to this map and I'll go to properties and make sure that my coordinate system is set to be Geographic Coordinate Reference System, World, and WGS 1984, and that should take care of the distortion that we basically saw. And now if I zoom into New York City, just like this, you would be able to see this point dataset. Well, at the beginning of this second example, I told you guys that the type of chart that I'm going to create from this dataset is going to be a time series. So how exactly are we going to create a time series from a point dataset like this? Well, if I right click over here on this new dataset that I created and check the attributes table, sure enough, you can see that we see basically the same attributes that we saw, the same fields that we saw just a few minutes ago from the CSV file. And right over here, we have the crash date starting from 1st of January 2020 all the way until, well, we have date until the end of August 2020. So this is the dataset that we're going to work with, and from this object ID you can see that we almost have, well, more than 74,000 data points. And now what I'm going to do is I'm going to right click over here and go to create chart, and this time instead of selecting bar chart, I'm going to go with this line chart. And similar to what we saw before, you can see that right along with this attributes table, an empty chart or an empty space for our chart gets opened up right next to that. And with that, under chart properties right over here, you can see that now we can set the date or the number. And if you can recall, we basically had a crash date column. So that's going to be my selection for this entry right over here, which is going to be crash date. And from here, you can basically go with count in this particular example, because what I'm essentially trying to do is I'm trying to count the number of accident incidents that happened, well, each day to get started. For example, you can see that if we refer to 1st of January, we have how many data points? If I select and just scroll down like this, you can see that it's still 1st of January. So quite a number of crash incidents that happened in 1st of January. What I'm trying to do is I'm just trying to scroll down manually until I get 2nd January. Just so that I could sort of isolate all the records of 1st of January. Well, there are easier ways of doing this, but I'm just doing this manually just for the sake of showing you guys. Well, 336 is the number of crashes that happened on the 1st of January of year 2020 in New York City. But as you saw, that grouping, if I were to do it manually, it's going to be quite a tedious task. So if we head back to this chart that we created, you can see that as long as I'm selecting count, it's going to basically count the number of different records that we have over here, just like what I did manually. And something else that's going to be quite important for you guys is actually going to be determining the interval size. So let's say if I want to go with an interval size of 1 day, that means I will be creating a data point in this graph for each day of the year. So what it's going to do is it's going to go back to this table and it's going to count the number of different records that are corresponding to each unique day. And it's going to create a data point like this. And the days are going to get assigned to this x-axis, as you can see over here, starting from January 2020 all the way until the end of August 2020. And over here on the y-axis, what we have is basically count. So if we select one day, if you can recall, the very first data point should be 336, as we saw right over here. And you can see that immediately on the next day, the number of data points has, well, risen up to 409. And on the third day, it has risen up even more to 452, and so on. So this is basically an example of a time series graph which shows the number of accidents that happened each day in New York City from January 2020 until the end of August 2020. However, if you don't want such fine detailed resolution, what you can do is you can actually play around with this interval size. Now let's say instead of having a one-day aggregation, if you would like to maybe have your data set with a weekly aggregation, you will see that the graph gets smoothened out. You don't really have those spikes that we saw before, because now if you just take your mouse pointer to right over here, you can see that the crash date is not basically showing the count just for one day, but it's showing the count for, well, 1 week. So that's why the number of accidents is now 2,687, which is the total number of accidents which happened during the first week of January in year 2020. And what's interesting is that you can see that immediately you can start making certain inferences just by looking at this graph itself. For example, you can see that for some reason from April to May, somewhere around the second week of April, you can see that the number of accidents has drastically dropped. Now if I click right over here, you would be able to see where those accidents actually occurred right over here on the map itself. Now, why this pattern looks like this? I mean, what is the reason why suddenly the number of accidents dropped down to almost 800 compared to the number of accidents right over here is 3,600, which is basically over 4 times the number of accidents that happened right over here. Well, interpreting the reasons for that specific pattern or behavior when it comes to accidents during these different times of the year might not really be part of today's tutorial, but you can definitely see that this kind of analytics can definitely open up new ways of thinking and making inferences based on the datasets that we have in hand. We can even go for aggregations. Let's say if you want to go with a monthly aggregation, well, the graph might not really look that nice. However, you still can see this pattern where the number of crashes drop down by the second or the third week of April, and it's starting to pick up again. Let's put this back to a weekly aggregation, just like this. So guys, this is how you can work with time series data. As long as you have a column which shows either date or date and time, you can create your own time series graphs and make interpretations based on the datasets that you have by creating this kind of a line chart. Alright guys, with that, let's move on to the final example that we are going to talk about today in this tutorial, and that's going to be how to create histograms. So to demonstrate the third example, I'll be using a dataset which shows some house prices and some associated details in California. So let's go ahead and open up this dataset. So just like what we saw, you can see that we have longitude, latitude, which basically should help us to create a point on our map. And with that, for each point or each record, you can see that we have some statistics like housing median age, total rooms, total number of bedrooms, well, population, households, median income and median household value, and finally the ocean proximity, whether it's near the bay or less than 1 hour to the ocean, things like that. So what we can do is we can again close this window, because as you know by now, we can import this dataset into our ArcGIS Pro workspace simply by dragging this CSV file and dropping it over here, which will create a standalone table. And if I right click and go to display XY dataset, and as long as I map the Y field to latitude and X field to longitude, I should be able to create an array of points over California just like this. And if you go to attributes table, again, sure enough, you would be able to see the same fields or the same attributes that we saw just a few minutes ago. Now I think if you want to create a histogram based on what we did during the last 2 examples, if you right click over here, you can again go to create chart, and this time you can go to histogram. And this time as the variable, well, you can go with a number of different variables, but for this, what I'm trying to see is the distribution when it comes to, let's say, something like the median income of these different data points. So if I select median income, now you can see that we actually get a very nicely formatted histogram with a number of different bins like this, and you can decide to apply transformation if that really serves any specific purpose that you're after. But in this case, I'm not really going to apply any transformation. I'm just going to retain this skew that I get originally with the original dataset when I plot it as it is. And over here you have the option to control the number of bins. Well, basically the bins refer to the number of bars that you get over here. So within this range of median income, if you would like to maybe go with a higher number of bins, you can see that the intervals are actually getting smaller as you increase the number of bins. And at the same time, you would also be able to see some statistics like the mean, which is about 3.9. By the way, if you're confused about the median income, what sort of a unit has been used over here, well, I downloaded this dataset from Kaggle, and according to the description, the median income is given for households within a block of houses measured in tens of thousands of US dollars. So that's what this number right over here basically means. And what sort of inferences we can make from a dataset like this. So let's say since we're talking about distribution of median income, you will see the average values somewhere over here. So the average happens to be right around here, which is around 3.9. But if you would like to visually see in which geographical regions within California people with highest median income according to this histogram are located at, what we can do is we can go to the edge of this histogram and pick this bin right over here, which shows the median income between 14.6 and 15. And if I click right over here, you would be able to see that specifically out of all these different points, you can see that the highest median income is sort of concentrated in two different cities. And if you deactivate this dataset for a second, you can see that sure enough it's going to be in San Francisco as well as in Los Angeles, well, over here in San Diego as well. So when it comes to visually seeing the highest median income and the places where those points are geographically located at, this kind of histogram can be really helpful, especially when it's working in conjunction with a map like this. At the same time, you can see that when it comes to the lowest median incomes, whether really you can get this kind of a clustering around certain cities or not simply by clicking right over here. However, you can see that it's not really that apparent, just like the highest median income bin. If you check the bin which corresponds to the lowest median income, it's kind of scattered around. However, I do see a bit of a higher density of points right over here as well in Los Angeles. And along with that, you also actually get these other types of statistics as well. If you would like to basically display the median of this median by a line, you can do that as well. And you also can display the standard deviation lines just like this. And let's say if you're interested in seeing how these values are correlated to each other, you even can do something like that simply by right-clicking over here, and if you were to create maybe a scatter plot, let's say if you're interested in seeing maybe a relationship between total rooms in y-axis and, well, the number of households, you can imagine that the relationship should be something linear like this. As the number of households increase, well, the total number of rooms should typically increase as well. So with this kind of a scatter plot, you would be able to see the relationship between two different variables just like this when you plot one of them in x-axis and the other on y-axis. And what's cool is that it basically shows us the trend line as well, along with the equation right over here, y equals 0.16x plus 75.3. How useful this information for this particular example, well, that might be a discussion to be had, but I'm just throwing out there that this kind of scatter plots can also be drawn if you really would like to see the relationship between two different variables. And coming back to our very first example of creating a bar chart. Now, if you would like to get some quick statistics about the ocean proximity of each of these different data points, what you could do is you can again go to create chart, and this time, let's say if you were to go with a bar chart, over here under category, you would be able to select ocean proximity. And let's say for aggregation, if we decide to go with the summation of maybe the number of households, for an example, sure enough, you can see that we get a graph like this, and let's say if you wanted to just get a quick statistic about the houses that are located near ocean, all you have to do is just click right over here, and sure enough you can see that all the houses along the coast right over here get selected. And if I put my mouse cursor over here, you can see that the sum of the households comes up to about 1,332,308. And similarly, if you just would like to group only the houses that are, well, let's say less than 1 hour from the ocean, based on this categorization right over here, all you have to do is just click right over here, and you can see that a strip of households or a strip of points right along here gets selected, and we get the sum of households as 4,730,118 households based on this bar of this bar chart. Alright guys, so that's about it for this tutorial. I hope you guys got a good understanding or a basic understanding about using the graphing capabilities of ArcGIS Pro when it comes to handling different types of datasets and generating quick insights from the different datasets that might be really helpful in your data analysis tasks, especially when working with the geospatial datasets like this. So thanks a lot for watching guys. If you do have any questions, just add a comment down below. And if you'd like to stay tuned for interesting tutorials like this, don't forget to subscribe to this channel as well. And this tutorial is just a part of a collection of ArcGIS Pro tutorials. And if you would like to see the other tutorials of our ArcGIS Pro tutorial series, don't forget to click on the playlist that you're seeing right now on the screen as well. So until next time, take care, and I'll see you guys again with another tutorial soon.